Hello, this is Tucker from the Math and Physics Resource Center at SVSU, and in this video we're going to go over the factorial rule for stats. So the factorial rule is pretty similar to the counting rule in the last video, but that'll become apparent once we start doing an example. So, example 1, a baseball team has 25 players. How many different batting orders are possible? So basically, how many different orders can we arrange those teammates out of 25 people? So in the counting rule problems, remember we had different slots for the outcomes in each individual thing. So for the first slot in this batting order, we've got 25 different options of people to choose. So we can choose one of those 25 to be the first in the batting order. But from there, when we're choosing the second person in the order, we only have 24 total people to pick from. So because we're not replacing the people into the pool over and over again, our pool of total players to choose from is going to decrease every slot. So down to 22 and so on, all the way down to 1 in the last slot. So you might recognize this kind of pattern because remember, with the counting rule, we're multiplying all of these numbers together. This is actually going to be a factorial. So 25 factorial. Remember, factorial is just all of the numbers starting from the initial number 25 multiplied to itself over and over again. So we've got 25, 24, 23, and so on, all the way down to 1. So for this problem, because it's decreasing every time, we can say that the total number of outcomes here is going to be just 25 factorial, which is roughly, it's a huge number. It's about 1.55 times 10 to the 25th, which is just massive. So that kind of puts into perspective how many different options we've got here. So moving to example 2, we've got a similar problem. A deck of cards consists of 52 different cards. How many different ways can this deck be shuffled? So again, we could go through and do the slots that we were doing in the last video with the 52, 51, 50, and so on, but that's a lot of work. So because we know that it's going to be decreasing by 1 every slot, again, we can use the factorial to express that easier for us. So 52 factorial will be the different, or how many different ways you can shuffle that deck. So 52 factorial, again, is a huge number. I'm going to have to round it off. So it's 8.066, roughly, times 10 to the 67th, which, again, is a massive number that you won't want to write out entirely. So generally, this factorial just kind of makes it easier for problems like this to write out our work, because you don't want to go down 52 slots, essentially. So that's about it. Thank you for watching.